Hey, what's up? My name's Alan Gatewood, aka the Curry Master, master of everything, and today we're going to be taking a look at potato cannons. A potato cannon is a pipe-based cannon, and there are three types: vacuum cannons, pressure cannons, and combustion cannons. Vacuum cannons works by creating a vacuum in a chamber that is sealed off by burst discs, but a projectile is at one end, and when one burst disc at the end of the projectile is ruptured, air comes rushing through, forcing the projectile to follow its path. A pressure cannon consists of a barrel with a projectile at the end. Connected to it is a pressurized tank which will release all of its pressure as fast as possible into the barrel, forcing the projectile out with it. And a combustion cannon consists of a barrel with a potato at the end of it, and connected to it is a combustion chamber. When fuel is added in the right conditions and ignited, the gases will expand rapidly, having nowhere to go but forcing the potato out the barrel. Our cannons will need three fundamental things to operate. Fuel, I'm going to be using brake cleaner. Anything that has a flammable symbol on it will work. Air is an oxygen. This will help our combustion actually combust. And we will need an ignition source. In this case, I will be using a spark. Also mandatory is a combustion chamber, a barrel, and a projectile. In this case, of course, we're going to be using a potato. Now let's take all of these things into account and let's design our potato cannon.
Enchanté.
Now, as you can see, with this super simple design I created, all of the fundamental things for a potato cannon to operate are introduced into this diagram. There's a place for the gases to combust, an area for the projectile to gain speed, and electrodes for a spark to be created. I think focusing on the length of the barrel will make a significant impact on the projectile speed. If I were to have a longer barrel, there will be more time for the projectile to speed up from the compressed gases, therefore increasing the speed of the projectile. Compared to if I have a shorter barrel, I think there won't be enough time for the projectile to actually speed up, and it would be inefficient. Now, with everything that we need to know, let's get into the build. This is what I'm picking up from Home Depot: ABS cement, a threaded end piece, and a coupler. And I'm gonna grab this humongous barrel. The reason why I only grabbed these many items is because I already had most of the stuff at home, and I also got a lot of the things on Facebook for a quarter of the price. And even though I show all the materials used in this project, I will not be showing the exact measurements for all of the pipes I've used, as this is an extremely unsafe project and I wouldn't want to be held responsible for anyone's injuries. Also, some important things to note here: ABS has to be on a clean surface. The surface has to be completely clean for it to adhere properly. Also, you've ever smelled. Here I'm gluing a coupler onto the barrel. This will connect the barrel to the combustion chamber. I'm also making sure everything is properly seated, as I don't want this thing coming apart. And here I'm gluing the combustion chamber onto the coupler, connecting it to the barrel. And as you can see, this thing was massive. Here I'm preparing the area where I'll add the end piece to the cannon. This will serve a purpose where I can add fuel and where the electrodes will be in the potato cannon. Now what are we waiting for, boys? We're ready for war. Woo! Oh wait, before we drop into Tilted Towers, I think we're forgetting something. One of the 3 fundamental things was an ignition source. For our cannon, I will be using a spark. And this is how I figured that out. Guys, so I didn't know what to use for an ignition source, so I thought, and my barbecue has an electric starter in it. Like that. Yeah, there you guys go, you can see that. And I quickly figured out the whole thing just unscrews and falls right out of place. This unscrews too. I think that's, yeah, that's... Yeah, and this is it right here. I'm hoping these wires should just pull out. Then just screw right in. And this generator was extremely powerful. According to a Google search, it created around 15,000 volts. Though, remember the current is fairly low. Now, to harness this power, I drilled 2 holes in one of the end caps and put 2 screws in the back to act as electrodes. Testing it out, it worked fantastically. That's insane. That's a whole taser, bro. Guys, I'm in the bathroom to show you how powerful this is and how it works. But as you can see, there's a problem. Why is it only sparking right here? What we learned in our physics class, that electricity likes to take the shortest route possible. This is a perfect example here. It sometimes works there, but it likes to take the shortest route possible. So I have to isolate these things. Pretty cool though. It's really powerful. Now, I'm going to stop boring you guys and let's get into some shooting. I drove over to a local new park in my area and... I think we're okay. Our activity's not prohibited, so I think we're all set. I picked out a baseball diamond and quickly began to unload my things. I set up the overly large potato cannon first, but I was kind of unimpressed with the shots I got. Now, even though this may look impressive, I really felt like there was something holding me back. After taking a look at one of the clips, I figured out that the combustion would complete, but the barrel was so long that the potato took a while to exit. Playing this video back one more time, you can hear the combustion complete. And then the potato leaves the barrel. And the contributing factors to that, I think, are, of course, the ridiculously long barrel, which would definitely cause a lot of friction. The size of the combustion chamber was too small in width, but way too long. And this would often cause an incomplete combustion of the dasher. Taking into account all of these factors, I went home and I designed a new potato cannon. This one had a much shorter barrel to prevent friction and a much larger combustion chamber. Now, with the cannon complete, I'll head back to the park and let's see what shots we get. Oh, and this cannon was a lot more powerful than the first generation. We can double check this by using physics to calculate the muzzle velocity of the potato traveling out of the barrel. First, let's calculate the muzzle velocity of version 1. To do this, I will go into my video editing software. Then, I will slow down the clip that I shot in 240 frames per second down to 60 frames per second. This will give me a 25% reduction in speed, or 1/4. Then I will proceed to time how long it takes for the potato to travel across the Bristol board, measuring 203 centimeters in length. So we know that velocity equal to distance over time. The potato traveled 203 centimeters in 51 milliseconds. We have to multiply that by 4 because we slowed down the original clip 4 times in post. That gave me 2.04. So now 203 divided by 2.04 equals 99.5. I have to times that by 60 because there's 60 milliseconds in a second. That gave me 5,970.5 centimeters per second, which is 214.9 kilometers per hour. Now for version 2. I will proceed to do the exact same steps, but I'll show you what will happen if I didn't multiply by 4. It took me over an hour to figure out that I had to multiply by 4, so I actually believed this was a number for a bit, but it obviously isn't. If I were to have done 203 divided by 0.11, I would have got 1,845 centimeters per millisecond. Timing that by 60, I would have got 110,727 centimeters per second. And that is a whopping 3,986 kilometers per hour. That's 3 times the speed of sound at Mach 3. I don't think anyone would want potatoes flying around at Mach 3. But in all seriousness, dividing 203 by 0.44 gives me 461. Multiplying that by 60 gives me 27,681 centimeters per second. And that is 996 kilometers per hour. That is insane! And that is still faster than the top speed of the Boeing 747 at 920 kilometers per hour. So you know, you're just chilling on a plane and you'll see a potato fly right past you. We can also use physics to calculate how high this potato went. I can use this simple kinematic equation to figure out the total height that the potato traveled. Now, I think it's time for some sick slow-mo shots. Go. Ready? Yeah, ready. 3, 2, 1. Now, I want to show you guys something really cool. But first, I need to start a small fire. Did you know that cornstarch is actually flammable? Because of its super fine particles, when cornstarch is airborne, it becomes highly flammable. And this is how most grain fires and explosions actually occur. Make it airborne. So now, let's see what it can do in the potato cannon. I grabbed my cannon, loaded a potato into it, and then I started filling it with cornstarch. In the end, I had an absolute blast creating this project. I had so much fun and I actually made a couple friends. Now I know that there wasn't enough physics, but I think this project really demonstrates projectile motion in a really fascinating way. And I just want to give a big thanks to all the people that came out and helped me film this project. Home Depot for helping me out and all of the employees that showed a huge interest into my project. And I'll see you guys in the next video. It's more like potato melon.